Hello, I will be very brief with this presentation. Although there is a long presentation in the YouTube channel, or you can ask Kyle. So this project is about creating a graph network, a network that integrates the GBIF data and also binds other different type of information, matching the occurrence of or each record of the GBIF with the time and location. So the idea of this is that we could interpolate GBIF data or at any taxonomic level. So the idea behind is that I would like to infer what is the most likely assemblage of species or genus or families or any taxonomic element within an area, knowing or using as conditioned to the environment and the co-occurrence of other species in the neighborhood. So the data is distributed. We know that it's biased, so this will help in modeling a framework for estimating absences, for example, and how to account for these different samplings and cluster of the data. Currently I'm using 7 data sources, the canonic bioclimatic sources, and I'm binding each source with the occurrence. In this example, this has been done with the software I'm developing. So the occurrences are distributed in the entire territory, and each occurrence is binded to the pixel value where it has been found. And for each unit area, in this example, we can see different cells. So for each cell, I aggregate that information of the occurrences into the taxonomic tree. So this will give us information of the evolution of the communities. And this is a example of a chain. This would be the occurrence is binded to the different raster data, and the occurrence has a species, has a genus, has a family, and so on. This would be a chain because it has it's a path, no, from the root to the occurrence. This would be an example of a subtree. It's the same. So in each node here we will have a tree, a subtree, like in this example. And the idea is that how to derive a statistical model, a regression model for inferring the probability of having a certain tree or the most likely tree or assemblage of species in a given place in the earth. Well, I don't have time for explaining more. I could be very happy, but you can see the other presentation in the YouTube channel. This would be the model, statistical model, special with environment, the co-occurrence, which are the other taxa. This would be the node of the tree, the other taxa, and kernel function would be, which would account for the spatial autocorrelation. The software is based on Django. It's connected to Neo4j for the graph traversals database, and there's a Python notebooks, and you can download it from GitHub if you want to play. Maybe it's a bit difficult to install it, but you can ask me at any time. Thank you very much. Thank you very much for this project. I'm going to use the money wisely. I would like to hire some cluster and big data infrastructure for doing it for a lot of data or global. Thank you very much. Thank you very much.